folks, it is time for science. This is your screencast for Wednesday, April 29th and Thursday, April 30th in physical science. So today we're going to start really getting into our classifying reactions in the mole unit as we start to introduce scientific notation and perhaps one of the most important numbers in chemistry, the mole, which is also known as Avogadro's number. Sounds a little bit like avocado, which I think is a little funny. So, today what you're going to need to do is you're going to have the scientific notation and Avogadro's number handout from your packet. You'll go ahead and use the PowerPoint posted on Schoology to complete that, and then there's a backside which you'll take a picture of and submit that as your assignment to Schoology. This is really similar to last week, that I'm not asking you to take a picture of the notes and the practice, but rather I'm just asking you to take a picture of the practice so I can see that you understand and know what you're doing. Other things to be thinking about is make sure that you have done the molarity FET this week. If you did not do that yesterday, today would be a great day to finish that up to make sure that you're on track with the FET project. Let's go ahead and go into Schoology and take a look at that assignment really quick. So, in the assignment, April 29th or 30th, you'll see this assignment, and I will include the PowerPoint and the note taker, as well as the scientific notation, which is what you will turn in. So let's take a look at that. So, scientific notation and Avogadro's number, we first talk about how do we measure things, what do we use, some distances on Earth, space, so on and so forth. And if you remember the powers of 10 video, this is what we're starting to get you to think about. We have some things that are relatively small we can measure with a ruler, but we have some things that are really, really, really big and they need to be represented with different units. So, you'll have some practice, recall some of these measurements, and then we get talking about scientific notation. We talked about this a little already, but it's basically, if you'll remember, a way that we can represent really, really large numbers or really, really small numbers. So for example, the speed of light is 300 million meters per second. So instead of having to write 3 with 8 zeros afterwards, what we can do is we can put it into scientific notation and just say it's 10 to the 8th meters per second. This number right here is the same number as this number right here, but this just seems a little less unnecessary. Same with things that are really, really small. So like the mass of a dust particle, it's 0.00000000753 kilograms. So that's a 7 with 9 zeros in front. We could certainly say that is the mass of a dust particle, or we could shorten it and say it's 10 to the negative 10th kilograms. It's a lot easier for us to be able to do problems with and understand. And basically the way to convert is that you basically just have to move the decimal place over however many places on this exponent it tells you to. So for 5.78 times 10 to the third, if you're just given 5,780, you're trying to make it into scientific notation, you move this decimal over 3 places, so it ends up with 1 digit to the left and then however many digits to the right. And then how many places it is that decimal. So same with right here, 0.034. To make it so there's 1 digit on the left, we have to move it over 2 places. So then we take 3.4 and times 10. Since it was already a small number, it's a negative. So the negatives tell us that it's really, really small. The big numbers tell us, or the positive numbers tell us that it's really, really big. So, when this actually comes in handy is in chemistry is with Avogadro's number and the mole. And so the mole is just a really specific number, and it's 6.02 times 10 to the 23rd. And it's really, really big. If we say that you have 1 mole of cats, that means you have 6.02 times 10 to the 23rd cats. So there's a video here that kind of explains what is a mole, what are some examples of things that could be moles, and so on and so forth. It's really funny. It's kind of cute. It's not actually like the little mole animal or the mole on your face. There's a lot of things that moles can be, and the mole for chemistry is its own specific thing. So other than that, you're going to be working on the scientific notation practice. This kind of goes through a couple of examples of it. So in each category, they're all the kind of same things. You're taking really big numbers. Here's one where you're taking a really small number. Here's where you're going from scientific notation to standard form, both with a big number and a small number. And these are some optional extra credit. So you do not have to do 17 through 23. The instructions are there if you're using multiplication. It just tells you what you should do. But otherwise, if you want to do it, great. If not, I'm also not going to be mad if those are blank on your assignments. So this whole deal, you'll take a picture of it, submit it to Schoology, and that is it for today. In addition, I am going to give one more reminder to complete that molarity PhET in order to stay on track with the chemistry project. I wish you all the best. I hope that you're well, and we'll see you next time. Bye, folks.